Everyone, so we are going to start off with the human circulatory system. So let's get into the video. Human circulatory system. Okay, human circulatory system is also called as the blood vascular system. Blood vascular system, we can also say that it is a human circulatory system, and our human circulatory system consists of a muscular chambered heart and a network of close branching blood vessels and blood and the blood which is circulated, which actually transports the material into the in the tissues, or we can say to all the organs or all the tissues. And the heart is mesodermally derived organ, and it is situated in the thoracic cavity between our two lungs and slightly tilted towards the left. Okay, we think that our heart is at the left side. No, it is at the center of our body, but it is tilted towards our left side. That's why we think that it is at the left side, but actually it is not at the left side. It is at the center but slightly tilted to the left. Okay, and it has a size of a clenched fist, means that एक मुट्ठी जितना size होता है. It is protected by the double layered mesodermal bag which is called as pericardium. We need to protect it also, so we have the double layered membrane which protects it, and it encloses the pericardial fluid. Okay, and our heart has four chambers, and the upper two chambers are called as atria and lower two chambers are called as ventricles. A thin muscular wall called as interatrial septum. The role of interatrial septum is to separate interatrial septum. The work of our interatrial septum is to separate the right and left atria, and we have interventricular septum also, and which separates the left and right ventricle. Interatrial septum will separate the left and right atria, and interventricular septum will separate left and right ventricles. And we also have atrioventricular septum which separates atria and ventricle. Okay, and the opening, we have also walls in our heart, and that flaps or cusps, three muscular flaps and cusps. The valve which has three muscular flaps and cusps is called as the tricuspid valve, and the valve which has two muscular flaps or cusps is called as bicuspid. So we have two valves, and we have another opening which is called as a semilunar valve. Okay, let's move to the next page. Okay, I was not able to show this heart. Okay, so what is it saying? This is our heart. This is how our actual heart looks like. This is aorta. This is pulmonary artery, pulmonary vein, left atrium, bundle of his, left ventricle, interventricular septum. Look, it is separating the ventricles, left and right ventricle. It is apex. Right ventricle, this is chordae tendineae, and this is atrioventricular node. This is sinoatrial node, and this is vena cava. Okay. Next page. Our entire heart is made up of cardiac muscles only. Okay, it is made up of cardiac muscles, and the walls are much thicker as to protect it. Okay, much thicker. The ventricular muscles are much thicker as compared to the atrial muscles, and the special cardiac musculature is called as the nodal tissue, and it is distributed in our heart. And the patch. One second. Okay, so we have sinoatrial node and we have atrioventricular node. And the bundle of nodal fibers, atrioventricular bundle, continues from the AVN, which passes through what? Which passes through our atrioventricular septa to emerge on the top of the interventricular septum, eventually divides into two bundles, right and left bundle. Okay, right and left bundle. it gets divided later, and these branches give rise to minute fibers through the ventricular musculature in the respective side, or called as, these fibers are called as Purkinje fibers. Purkinje fibers. The nodal musculature, these branches, the Purkinje fibers, we call it, and the nodal musculature has the ability to generate the axial potential. They have to generate some axial potential without any external change or external stimuli. So it is called as auto-excitable because it doesn't need any external stimuli. It gets generated. The action potential gets generated uh, without any external stimuli. So it has the ability to generate. Okay, and it could be generated in a minute, and it vary from parts of different parts of the nodal system. SCN can generate maximum number of action potential, which is about 70 to 75 per minute. And it is responsible for starting or maintaining the rhythmic contractive activity of the heart. Okay, cardiac cycle. Cardiac cycle. Now we are going to discuss that how our heart actually works or functions. We know that we have the four chambers of the heart. First, they will all be in relaxed state. Okay, so they will be in diastolic state. Diastolic state. Okay, so they will be first at the relaxed state only. Okay, and they are in joint diastole, means the atrial and ventricle all will be in relaxed state, and as the tricuspid and bicuspid valves are open, blood will come from the pulmonary veins and vena cava. Then it flows to the left and right ventricle respectively. First it will go to the left ventricle, then it will go to the right ventricle, and through the left and right atria, and the semilunar valves are closed at that stage. SN now generates the action potential. Okay, action potential will get generated, which will stimulate the atria to undergo contraction, which is called as atrial systole. Atrial systole means that atrial will going to be contract in the contracting state. Contraction. Okay, and this increases the flow of water blood into the ventricles by 30%. It will increase by 30%. The action potential is conducted to the ventricular side by AVN and AV bundle, from where the bundle of his transmitted to entire ventricular musculature, and this causes the ventricular muscle to get contracted, and hence it is called it ventricular systole, because here ventricle is getting contracted. The atria undergoes relaxation when the ventricle is in contraction. So if atria is going to relaxation, then it is going to call as atrial diastole, and then ventricular systole increases, and the ventricular pressure causing the closure of tricuspid valve. And then what happens? That we'll come to know about in the next page. Okay. So what happens next? The pulmonary artery and the aorta are forced open, then it will allow the blood in the ventricles to flow through these vessels into the circulatory pathways. Now the ventricle are relaxed, so it will be going to call as the ventricular diastole, and the ventricular pressure falls, causing the closure of what is it? Closure of semilunar walls. Semilunar walls will get closed now, and the work of the valves is to prevent the backflow of blood into the ventricles. Okay, so it stops the blood to get backflowed. Okay, and as the ventricular pressure declines further, the tricuspid and bicuspid walls are pushed into the pressure in the atria, which will exert by the blood, and the blood now once again move freely in the ventricles, as there is no contraction. Okay, and the ventricles in atria are again in a relaxed joint diastole. They will be again in the joint diastole. At the starting also they were in the joint diastole, and later on it will be again in the joint diastole. Both the atria and ventricular are at relaxed. Okay, are at relaxed stage. Soon the SN generates a new action potential, and the events described repeated again and again, and the process will continue. Okay, and the sequential event in which the heart is cyclically repeated, and this process is cyclically gets repeated again and again by the sequential events. This is called as our cardiac cycle. It consists of systole and diastole, both the atria and ventricles. Okay, and our heart beats about 72 times per minute, and it in average we have 70 to 75 times per minute. Okay. Next is it is written that this cardiac cycle is performed per minute, and from it can be deduced like cardiac seconds. The duration of cardiac cycle is 0.8 seconds. Okay, and during a cardiac cycle, each ventricle pumps approximately 70 liter of ml of blood, which is called as stroke volume. Stroke volume gets multiplied by the heart rate, and it gives the cardiac output. Therefore, cardiac output can be defined as the volume of blood pumped out by ventricle per minute, which which averages about 500 ml to 5 liter in a healthy individual. Okay. Next it is saying that during the cardiac cycle we have two prominent sound which is produced by our heart. There are only two prominent sound which is very important produced by our heart, which we can hear through the stethoscope. First sound which is produced is called as is lub, L-U-P, lub, and the second sound produced is dub, D-U-B, dub. And the first sound is produced when the tricuspid valve gets closed, and the second sound gets produced with the closure of semilunar valve. Tricuspid and bicuspid when get closed, then we will hear the sound of lub, and when the semilunar valve gets closed, we will hear the sound of the dub. Okay, so that's all for this video. We'll cover the next portion in the next video. Thank you for watching.